All right. Today's warm-up, instead of being well, it is a review of a concept from the past, but it's an old concept, and it's more of a lead-in into today's lesson. So let's see how we're doing with this concept from long ago. Number one, what do you get when you simplify that expression? We got Sebastian, Sharik, and then Anita. Okay?
3x squared minus 5x minus 2.
Okay. What'd you get, Anita? Okay. So we got three different answers floating around. Alyssa?
3x squared minus 5x
So it comes out to 3x squared minus 5x minus 2. Now, if you have those exact same terms, but in a different order, as Sebastian said, for the moment, that's okay. After today, you're going to learn why it won't be okay. So Sebastian's is correct as well. Number two, what did we get? Start with Brandon, Hezekiah, and then Kayla.
7x minus 12.
Okay?
7x plus
Okay?
7x minus 12.
Okay. The correct answer is 7x minus 12. Now, number three is not a lead-in into today's lesson. Number three is an EOC question. And they love to ask this type of question. I'm going to explain what the theory is here in a moment. But which letter is the answer? Start with Kamoy, Zabari, and then Ann. D, okay. B as in boy?
No, D.
D as in dog. D, everybody thinks it's D. The correct answer is D. Now quickly I want to go over this because even though it's very important, it's not part of today's lesson. Basically what is being asked is, solve this equation, but then tell me which of these steps matches one of the steps in the process. Another way to look at it is this. Solve this equation, solve these. Which one of these answers matches the answer to this one? Let's take the approach of solving this and then getting one of these. What's the first step you would do in solving this equation in the original question? Ania? Distribute. So we would do this and this, and what would the result be of that? What would the result be, Sharik?
6x minus 2.
Good. So you see a 6x minus 2. Here you see a 6x minus 1. So we can immediately say, well, that's not going to be it. And here it's not done, so let's forget about that. And here's a 6x minus 2, so that might be it. What would the second step be? Second step. Brian? Yeah, you have to get this x to jump to the other side, so we add x to both sides. And that's where this comes from. So even though this looked like it's almost the same, this is a minus x and this is a plus x, this is also a minus x, this is the only one that will work. Okay? Comments, questions about that? All right, now numbers 1 and 2. I actually expected more confusion because of what we did last chapter. My students' brains start swirling around with confusing thoughts of what you're allowed to do. But these two situations are different than all of chapter 8. What makes these two situations different from all of chapter 8? Nisa? Yeah, these are all adding. Yes, I understand there are subtraction symbols, but basically that's adding a negative number. So this makes it totally different. So let's look at number 1. What were you supposed to do in number 1 to simplify that? Anne? Combine like terms. Give me a pair of like terms, Ann. 2x, negative 7x is negative 5x. Give me another pair of like terms. Another pair of like terms. Come on. 5, negative 7, negative 2. For my students who try to then add things together, you're not allowed to. These are not like terms, so you cannot go any further. Anyone have any questions about that? Now, number 2, important detail. This danger zone right here. What do you have to do with that? What do you have to do with that, Zabari? Yeah. This is really distributing a negative 1 here and here. The shortcut is you know what's going to happen. All the signs are going to flip. So the shortcut is this. Flip it, flip it, flip it. You flip the subtraction to addition, flip everything inside the parentheses. You learned that quite a long time ago. Comments, questions, concerns on any of this? Good. Today we begin chapter 9. I'm going to warn you now, it's going to be a lot. It's going to feel a little bit like it felt when we started chapter 4 long ago. Let's review what that felt like. Let's see if we can reach back. Chapter 3. You guys were totally fine here. Totally fine. Pretty fine. Pretty okay. It started getting a little tough. And then we came over here and bam! What the heck is going on now? Graphing equations, intercepts, calculating slope. Oh man. That was a nightmare. And then when we got to chapter 5, some of you guys still struggling with concepts from there. So it's going to feel a little bit like it felt way back then. Everything you've learned already will be incorporated. But we're going to be starting a whole new set of language. So in a moment, I'm going to show you the language that you're going to have to start with. And I'm going to be front-loading you with a lot of language. What that means is I'm giving you a lot of new terms today that we're going to be using for the next 3 months. Okay? So, first let's get an overview of the chapter. Chapter 9. You do not have to copy this, you need to read it. 3 major goals, and within those major goals are lots of smaller goals. We're going to be adding, subtracting, and multiplying polynomials. We're going to factor polynomials, and we're going to solve polynomial equations in factored form. Unless I'm a complete lunatic, I think there should be one incredibly burning question floating around in your mind right now. Anyone have a burning question in their mind right now? Here's a guy. Yeah. What the heck is a polynomial? Well, welcome to chapter 9. So, first, today we're going to add and subtract polynomials. What I would like you to do is take a few minutes and you're going to start copying some of the new terminology and their definitions. Use abbreviations, but don't use abbreviations on anything new. Use abbreviations like on expression and exponent, variable. Can't use the same abbreviation for exponent and expression. You got to be careful with that. Okay? So I'm going to give you a couple of minutes to start, but what I would like you to do is leave a little space to the right of each definition because we're going to fill in an example that we're also going to put little notes on. Okay? take a couple minutes to go ahead and get some of this down. There are a few more at the bottom. Don't worry, they're a little bit shorter, and we'll get those filled in after. So now we're going to start trying to establish that vocabulary, the way that we're going to be communicating about certain ideas. So the burning question was, what is a polynomial? So a polynomial is an expression. You've actually been studying them since the beginning of the year. You just didn't know they were called polynomials. Here is an example of a polynomial. That is a polynomial. Negative 3x plus 8 plus 4x to the third plus 10x squared is a polynomial. Each term can be expressed in the form ax to the k power, where a is a number and k is a number. Now, what's the exponent here? What's the k? The k is 1. The k here is 3. The k here is 2. Well, look at this term. I don't see a variable and I don't see an exponent at all. But now we use something you learned last chapter. I can add in an x to the 0 power. 8x to the 0 power is really 8 times 1, which is the same thing as 8. So, even though that's called a constant, it still meets the definition of a term. Any questions so far? All right, so that's a polynomial. Now, what is a degree? A degree is the exponent of the term. So, I'm going to use the same example. And so, the degree here is 1. The degree here, 0. This is a third degree term. And that's a second degree term. So the degree is the exponent. Now we take that idea and we take it one step further. Every polynomial that we work with has an overall degree. And the overall degree of a polynomial is the largest degree of its terms. So I'm going to use the same expression again. And now, what's the degree of the polynomial? The degree is the largest exponent. So that's a 1, that's a 0, that's a 3, and that's a 2. Which means that this is a third degree polynomial. The largest exponent is 3. Any comments or questions so far? Now, during the warm-up, question number 1. A lot of you got it right, but express the answer differently. Sebastian and Sharik both had the same answer, except Sebastian's order and Sharik's order was different. And I said during the warm-up that they were both correct for now. Starting right this moment, that will no longer be the case. Because when you write something as an answer, you always write it in standard form. Now, I know there's something called standard form when we talk about linear equations. Standard form of a linear equation is that form that you've got memorized and it's back there on the back wall. Standard form of a polynomial means that the terms are in order from largest degree to smallest. So now I have taken the exact same expression, but now I have put it in standard form, and their exponents are descending. 3, 2, 1, 0. That is standard form. Are there any comments, questions so far on all this terminology that is getting thrown your way? For now, it seems new. By the end of the week, it'll be second nature to you. We will be using these terms constantly. All right. Leading coefficient. You probably don't even need a definition for it because if you just think of the term, it makes logical sense. What is the leading coefficient of this expression? Go ahead, Sharik. What do you think it is?
4.
Yeah, it's the leading coefficient. It's the coefficient in the lead. It's the one that shows up first when it's in standard form. So you have to put it in standard form first, and then you can get the leading coefficient. Any comments, questions? Now, let me shift gears for a quick second. I want you to think about one of your family's cars. And I would like you, when I call for volunteers, to raise your hand and tell me what kind of car it is. Not the make and model, but what would you classify it as? Okay? So think about that for a second. So let's see if we know any car terms. So go ahead. What do you got, Tristan? A minivan. Excellent. I love what you said. Beautiful. Brandon? Truck. Is it a pickup truck or is it another kind of truck? Okay, it's a pickup truck. Okay, awesome. Zavari?
SUV.
An SUV. I got 3 already. You took yours? Sorry. A car?
I don't know, it's called like a Honda.
Okay, well I have a Honda Civic and sometimes it's called a sedan or a coupe. It's got a few different names, right? Sports car, okay. This guy? A Jeep, okay. So we got like 6 different terms. Now here's the thing. Here's the thing. Let's pretend for a moment that you were standing up in the front of the building and I was over here and here came your parent and I said, oh, hey, there's your car. Would you know what I was talking about? But what if I said, hey, there's your SUV? Would you know what I was talking about? Either way, you know what I'm talking about. Because SUV is a subtype of car. They're all cars. But then we have more names. In the United States, we love our cars. We give them a zillion different names. That's actually one way you can tell in different languages what is valuable to that culture based on how many words they have for one particular item. Think about the number of different words we have for shoe, and that will tell you how much value we put on shoes, because we have 50 different terms for shoe. High top, low top, tennis shoe. Yeah, I mean, it's endless. Same thing with cars. Okay, so, all right, back to here. So these are all called polynomials, but there are subtypes, and here they are. There is a monomial. A monomial is a polynomial with only one term, and here's what it could look like. A monomial. And yes, you have to know what it is, you have to know how to say it, you have to know how to spell it. A monomial. A binomial is a polynomial with 2 terms. And here's what it could look like. 2 terms. And then lastly, a trinomial. A trinomial is a polynomial with 3 terms. And here's an example of one. If it goes beyond 3 terms, then you don't have a subtype for it, you just call it polynomial. Just like Kamoy did. Kamoy did not know what subclassification her car was. So she called it, excuse me, a car. That was perfectly acceptable. So if you don't know the name of a polynomial because it's beyond 3, then you just call it polynomial. But you do have to know these 3 terms. Are there any comments or questions? Good, we're doing well so far. And I know it's a lot to take in. It's going to be even more. So now we're going to learn how to use these terms by looking at a bunch of different expressions and trying to figure out what fits into which category. If you are missing something from here, don't worry about it. I have my notes right here printed out, and you could borrow them and fill something in. So now, we're going to explore a bunch of different expressions, and we're going to determine whether or not they are a polynomial, what the degree is, and what name we should call it. Now, there are a few rules about whether or not something is a polynomial, and I'm not telling you the rules, I'm going to show you what they are. So you won't know it until you see it. So, I have a computer to draw a perfect table for me. You don't need to do a perfect table, just simple, quick 4 columns, no big deal. So the first expression we're going to explore is just -3. That's it. And the question is it a polynomial? Yes, it is, because it could be written in the form -3x to the 0 power. And so that makes it a polynomial. What is its degree? Well, again, the degree of the polynomial is its largest exponent. The largest exponent is 0. That is a 0-degree polynomial. Now its name. It's either going to be monomial, binomial, trinomial, or polynomial. Which one do you think this one is? Ania? Very good, and you said it perfectly. It is a monomial. Any questions so far? All right. What about -d plus 1? Well, this is -1d to the first power plus 1d to the 0 power. So yes, this is a polynomial. What is its degree? Anyone starting to understand degrees already? What is its degree? Alyssa? 1. You're looking for the largest exponent, and that is its degree. What will its name be? Sebastian? Yeah, there's 2 terms. It will be a binomial. Excellent job. Any comments or questions? All right. What about this nasty-looking expression? It's pretty similar to the one I used for the other definitions. So it should be pretty clear to you that this is a polynomial. What is its degree? Caleb? Yeah. Highest exponent is 3. It's a 3rd degree polynomial. What is its name? What is its name, Tristan? Polynomial. We don't have another name for it, so we just call it poly. So we're going to do quite a few more, but here's where I'm going to start throwing in examples that are not polynomials, and I'm going to explain why. Now, keep in mind that you don't actually have to know these rules this year. My job for you this year is to just expose you to these rules. They will become important in Algebra 2. So here's an example of something a little bit different. 6n to the 4th power minus 8 to the nth power. A polynomial may not have an exponent that is a variable. That is technically not a polynomial. And so we can simply just say, no, this is not a polynomial because of that. And then we don't give it a degree and we don't give it a name. So one rule is can't have an exponent, you can't have a variable as an exponent. Here's another one. Z to the negative second minus 3. Now, this looks like it's a polynomial, but you learned last chapter what a negative exponent really means. So let's just look at this for a moment. Could someone tell us what that really says? What does it really say, Alicia? Very, very good. So that is really 1 over z to the second minus 3, and a polynomial may not have a variable in a denominator. Again, you don't have to remember this year, but I am exposing you to it so you're getting a sense of some of the rules. So no, this is not a polynomial because you're not allowed to have a variable in a denominator. And then we don't give it a degree, we don't give it a name. And 4b to the 4th power c to the 1st plus 17b to the 1st c to the 3rd. And this is kind of a hybrid. We're not going to deal very much with these. I'm exposing you to this so you see it. This is a polynomial because even though it's a little more complex than, for example, this up here, it still, for the most part, meets the rules. So it is a polynomial, but the next part you would never know unless I told you. The degree is actually you add the exponents of the largest term. So here's a 4 and here's a 1. That's a 1 and that's a 3. 4 plus 1 is 5. 1 plus 3 is 4. That's bigger. So this degree will actually be 5. That's not something you need to know this year, but it is something that you need to be aware of. Now its name you do have to know. What is its name? Got 6 people are catching on. 7. Anissa? Yeah, it's a binomial. Very good. And I have one last one that you don't need to copy down, but I wanted to show you that, I don't know what happened, it's supposed to look more like a fraction, 9 over v. But for the same reason that this one was not a polynomial, that's the same reason here. You cannot have a variable in the denominator. Okay? So, here's what we've done so far. We've established the language. We've explored what they look like in different parts of them. We've classified them. The one thing we haven't done yet is work with them. And so that's what we're going to start now. So, example 1, we are only doing one example. There's a reason. The reason is you already know how to do it. You have just never done it in this context before. So, example 1. Find the sum, then write in standard form. We have a polynomial here, adding another polynomial. We want to simplify this and then write it in standard form. What you and I are going to do together is take care of both of those details at the same time. Basically, this is just combining like terms. Because even though this is a polynomial and this is a polynomial and we're adding them together, really what we're doing is this. If you think about it, is it any different than if we did just all of that? Because everything's being added, that's the same thing. So what we want to do is look for what we were looking for during the warm-up, like terms. But since we have to write it in standard form, we want to look for the highest degree first and work our way down. So could someone identify the highest degree for us out of all of this? What's the highest degree that you see? Shelby? Yeah. So I see an x to the 5th power right there. Are there any partners for the x to the 5th power? Are there any like terms that are going to go with it? There are none. There are no other x to the 5ths. So what we'll do is cross that out. We're done with it. And now it becomes part of our answer. What's the next degree? Next degree. Ania? So there's a negative 2x to the 4th. Are there any other terms that have the same variable and exponents? Ania? Well, does it have the same variable and the same exponent? Okay, so no, there are no others, so that's done. So we'll cross it out, and we'll put minus 2x to the 4th. What's the next degree? Eric? So we've got this positive 7x to the 3rd. Does it have any partners, Kezekiah?
Yes.
Negative 3x to the 3rd. And so now we have to combine like terms and then simplify and put the answer right here. So this plus this, what do we get as a result? Kamoy?
Plus 4x.
Very good. Plus 4x to the 3rd. Outstanding. The next degree, what do we get? Stephanie? Good. Positive 12x to the 2nd. Are there any partners for that? Kasara?
Yes.
Excellent. 11x to the 2nd. And so we have to combine them and write the expression right here. What do we end up with, Brian?
23x
Plus 23x squared. What? Got my squared. What's next? Sharik?
Negative 8x.
Okay. Sorry. Negative 8x. And does it have any partners?
Yes. 8x.
8x. And what happens when we deal with those two?
They cancel each other out, so you're really left with nothing.
Yep. And then we have a negative 3. And there's no partners for that. And that's it. So we have added two polynomials, and we put it in standard form all at one shot. And so this is simplified. Are there any comments or questions on how we did that process? Comments or questions? All right. Now, subtracting. Find the difference and then write in standard form, although we actually have two operations being done. We have subtraction here and addition here. But it doesn't matter, because you already know what to do. What if I took all of this off? What if I took this, and I took all of that? What would you do to that expression what would you do to it? Maria?
No, distribute.
And what's the shortcut for that? Sort of. I use a different word because if you're saying change everything to negative, so that's negative already. Do I leave it negative?
No.
Okay. Okay, so the term I use is flip because I think of it as a light switch. If it's off, turn it on. If it's on, turn it off. That's what I mean by flip the sign. And so what we're going to do is this. Flip it, flip it, flip it, flip it, flip it. Now, if I put the rest back, I've just got one big giant addition problem. This is something you've learned to deal with since way back with Ms. Cooper when she taught you keep, change, change. And so just partner up and start with the highest degree. What's the highest degree in this one? Kayla? Yeah, so we've got x to the fourth, 11x to the fourth. Add them all together. That's 1, that's 2, that's another 11. 13x to the fourth. Find the next degree. Tristan? X to the third. No partners for it, so that's it. Plus x to the third. Keep going. And we'll go a little bit faster. X to the second I see right here, no partners for it. X to the second. X to the first. We've got a negative 1x to the first and a negative 2x to the first. That's negative 1 and negative 2. I get negative 3x to the first. And then I'm finally left with just the constants. 5, negative 8, and 6. 5 and 6 is 11, minus 8 is 3. I'm done with those. And once again, since we started by just looking for the highest degree, we have it in standard form already. Comments, questions, concerns on how we did this one? All right, so here you go, checkpoint number 1. Let's see how you do on your own. You got 2 minutes. Remember, checkpoints you don't have to copy unless, of course, you need it copied. So it's up to you to decide. All right. We're going to actually get our answer one term at a time. I'm going to need a bunch of people to volunteer because there's a few terms. So you're going to give me the term, and then I'm going to ask the next person to confirm it, and then give me the next one. So Jada, give me the first. 2x to the 6th. Sharik, do you agree with that?
Yes.
Okay, 2x to the 6th. And what's the next one, Sharik?
6x to the 5th.
Okay, Alicia, do you agree with that?
Yes.
And what's the next one, Alicia?
Negative 4x to the 4th.
Okay, Alyssa, do you agree with that?
Yes.
And what's the next one after that, Alyssa?
12x to the
Okay, Brian, do you agree with that? What is the next one after that?
Minus x squared.
Kamoy, do you agree with that?
3rd. Yes.
And what is the next one, Kamoy?
Plus 15.
Stephanie, do you agree with that? Plus 15. Any comments, questions, or concerns about checkpoint number 1? Okay, I'm going to put up the last example, and I'm going to talk a quick second about the story behind it. You do not have to copy the question, but we are going to work on it together. And of course, you have to read the question. So go ahead and read. You don't have to copy, just read. So, in this example, we're talking about population size. The process of studying populations is actually very complex science. These models for California and Nevada were constructed by a few sociologists using computer programs and a lot of work and a lot of data. Population is actually a very complex idea. Let's just think about our school for a minute. Can someone tell me how many 8th grade teams are there this year? How many 8th grade teams? Anyone know? Brandon? What are they? Jupiter is not an 8th grade team. Not an 8th grade team. No, there's 4. There's 4. Comets, Tritons, Apollo, and Lone Stars. There's 4. 4 teams. 22 students per team times 4. I'm sorry, 110 students per team times 4. It's approximately 440 students. 2 years ago, there were 5 teams. The Tritons actually was a new team that was added 2 years ago. There was another team before that called the Voyagers. I don't know why they got rid of the Voyagers, but they did. So why did that happen? It actually went from 4 teams to 5 teams back down to 4 teams. What's going on there, Maria? Okay, so there was more 8th graders and sort of more than it was expected, although we had enough time to plan, but think of the ramifications or the implications of that. An extra team, 5 teachers on a team, right? That's 5 adults who had jobs 2 years ago. Now they're either teaching somewhere else in the building or they had to go to a different school. 5 adults' lives completely different because of the population. Lunchtimes. The amount of food prepared by the cafeteria workers. What about guidance counselors? Guidance counselors have a certain amount of students that they're supposed to be addressing. How did we deal with that? Well, they had to divide up the grade. One guidance counselor took 3 of the teams, and another one took 2 of the teams. What about the assistant principal in charge of the grade? Now they've got 5 teams to be in charge of instead of 4. It's a lot more work. It's 25% more work. So the population, that one detail, changed everything. Completely different thing from that. Then it disappeared. Now those 5 adults had to, like I said, have to teach somewhere else, go somewhere else, or do something else. Now that lunchtime, no, doesn't exist anymore. What about those cafeteria workers? What if they had to hire an extra cafeteria worker to make the extra food to serve the extra kids? Now they're out of job. So the ebbs and flows, the fluctuation in population is actually a very important idea that a lot of scientists spend time studying. So that's the background behind what's going on here. So now we're going to use this idea just to do something fairly simple. And we're going to construct a new model. We have a model for California, and we have a model for Nevada. Now we want to create a new model, the model called P, that's going to be the combined population of California and Nevada. So this is where we're going to work together. And I'm actually going to divide up the work, and we're going to talk about why. Can someone tell us what's different about this example compared to the other ones we've done so far? What's different that you notice? Zabari? There's decimals, okay? What else is different? Brian? It's already in standard form. Both of them? Okay, come on. Okay, it's a word problem, so there's kind of some things to kind of work through reading-wise. What else is different? There's something nice that's different. Anyone notice something nice? Looking at this and then looking at that? What's something nice that's different? Anne? Well, yes, it is an equation. You're right. It's an equation because I put that C equals and that N equals. Okay? Well, considering that we have to add them together, what is nice compared to this one? What's the nice little detail? Alicia?
Like all the numbers that you have to stack up.
Well, I love the word you used. That was the word I was thinking. It's all stacked up on top of each other instead of like this. Oops, excuse me, instead of like this. And what Brian said was important, that it's all in standard form. So it's kind of all set up for us already. So we see the like terms right here. So let's divide up the work. So everyone in Sharik's column, you are in charge of the x to the 4th power. Everyone in Shelby's column, you are in charge of the x to the 3rd power. Everyone in Alicia's column, you are in charge of the x squared column. Everyone in Kamoy's column, you're in charge of the x to the 1st power. And everyone in Brian and Anissa's columns are in charge of the numbers. You got to combine the like terms. Go ahead, you got 30 seconds to a minute.
It says here.
All right, I'm going to call on a couple of people from each section to give me what you got. So let's start with Stephanie and then Eric. Stephanie, what does it come out to? Eric, did you get the same thing?
Yes.
That is correct. So everyone now, everyone in the room is writing along with me. 5.6932x to the 4th power. That's the like terms there. What about next? We got Kayla and then Shelby. Kayla, what'd you get? Okay, Shelby, did you get the same thing? Yeah, we get minus 183.321 x to the third power, and that's the result of combining those two. Next column, we got Dayanara and then Alicia. Dayanara, what'd you get? Go for it. It's okay.
2,171.
What'd you get, Alicia?
Same.
Yeah, you get plus 2,171.09 x to the second. What about and that's the result of adding those together. What about the x to the first column? We got Tristan and then Maria.
Okay, so negative 10,636.6 x.
Negative 10,636.6 x. And then unfortunately I ran out of room. You should be able to squeeze it in. I'll write my last term here. We got Jada and then Anissa. Jada, what'd you get?
4,540.
You get the same thing? Yep, that's right. Plus 51,547. And so what we have done is we've constructed a model for the combined populations of the two states. Now, x is the number of years since 1990. So if I wanted to study 1997, I would take a 7 and I would plug it in everywhere there's an x and simplify everything, and that would tell me the combined population for both states in that year. So if I wanted to study the year 2000, then I would plug in a 10. Plug in a 10 everywhere the x is, and then simplify everything. That would tell me the combined population for California and Nevada in the year 2000. Okay? Anyone have any questions on how we put these two expressions together? Yes?
So does that mean in 1990 the population was the last 2 years?
No, because this is only from 95 to the year 2001, so 1990 is not even accounted for in this. 1990 is part of the model because that's how they counted the number of years, but it actually will not tell you the population at that time. Okay? Good, we're doing a great job. Draw a line across your paper, and your classwork today is on page 92. You're going to do numbers 15, 14, 12, 10, 9, 6, 5, and 3. Here we go. Number 15. The area is 17/4 x squared, or you could have put 4 and 1/4. I would have taken that, or 4.25. X squared plus 8x minus 32. Number 14 comes out to 9x minus 1. Number 12 is negative 2m squared plus 9m minus 1. Me. Number 10, 6b squared minus 8b plus 1. Number 9 is 3x squared plus 6. Number 6 is not a polynomial because of the negative exponent. Number 5 is a polynomial. It's a third degree and it's a trinomial. Number 3 is a polynomial. It's a fourth degree. That's it written in standard form, and its leading coefficient is 4. So I know I need to go over 15, but I need to give you your homework first. So, draw a line across your paper, your homework. It's page 575, 12 through 34 even, 38 and 40. FL 17, day 1 through day 5, very important. Read the next section, incredibly important. And you're going to have a quiz. 9.1 to 9.3, and today it's going to be next week. I'll tell you exactly which day next time I see you.